Good morning, everyone. I am Mrs. Harshika A.V., Assistant Professor in the Department of Artificial Intelligence and Data Science. Today, I am going to discuss subject code AL3451, subject name Machine Learning, which is under Regulation 2021. In this session, I will be covering Unit 4, Neural Networks, specifically Gradient Descent Algorithm. Gradient descent is one of the most important optimization algorithm used in machine learning. Its main objective is to minimize the error or loss of a model by updating the parameters in the direction that reduce the loss. Gradient descent works iteratively. During each iteration, it computes the gradient of the loss function and adjusts the parameters step by step. This process helps models such as neural networks and regression models learn the optimal weights required for accurate predictions. Key points of gradient descent. There is three important characteristics of gradient descent. First, it minimizes the errors or predicting error of a model. Second, it updates the parameters gradually using gradient. Third, it helps machine learning model learn the optimal values of weights and biases, thereby improving prediction and accuracy. Role of gradient descent. Gradient descent plays a significant role in linear regression and other machine learning algorithms. It helps the model find the best values of weight and bias so that prediction errors become minimum. Initially, random values are assigned to the parameters, then the algorithm repeatedly adjusts these values in the direction that decrease the loss. This iterative process continues until the model converges to the best solution. The working of gradient descent involves four steps. First, random values are assigned to weights and bias. Second, the algorithm calculates how the loss changes with respect to these parameters. Third, the parameters are updated to the reduced the prediction error. Finally, the process is repeated until the loss becomes very small and best model parameters are obtained. Linear regression. Linear regression is a supervised learning algorithm used to predict continuous numerical values such as house price, temperatures, or sales. It especially a relationship between input variables and the output using a straight line called the best fit line. The objectives of linear regression is to minimize the prediction error and obtain accurate result. Logistic regression. Logistic regression is a supervised learning algorithm mainly used for binary classification problems. It predicts the probability that a data point belongs to a particular class. Based on the probability value, the model assigns the data point to one of the two classes. Next, softmax regression. Softmax regression is an extension of logistic regression. While logistic regression handles only two classes, softmax regression can classify data into multiple classes. It produces probabilities for all classes and assigns the class with the highest probability as the final prediction. Next one is neural network. A neural network with one hidden layer is capable of learning complex patterns that cannot be captured by simple linear models. By introducing activation functions, neural networks can model non-linear relationships and solve more complicated problems. Next, support vector machine. Support vector machine or SVM commonly used in supervised learning algorithm used for classification and regression tasks. It finds the best decision boundary called a hyperplane that separates different classes with maximum margin. Matrix factorization. Matrix factorization is a technique commonly used in recommendation systems. It identifies hidden relationships between users and items by decomposing the rating matrix into smaller matrices containing latent factors. The gradient descent is an optimization algorithm that minimizes the loss of machine learning models. It is used in various algorithms such as linear regression, logistic regression, softmax regression, neural network, support vector machines, and matrix factorization. Understanding gradient descent and its application is essential because it forms the foundation for training many machine learning and deep learning models. Thank you.